Part 2 of Lesson 1, Chapter 2, more on power functions and radical functions. On Part 1, we talked about looking at and focusing on two different things when looking at power functions, looking at the exponent to see if it's even or odd, and then looking at the leading coefficient to find out if it's positive or negative. That's going to determine what the graph looks like, and it'll tell you various things about your function. To continue off of that, I want to talk about fractional exponents. So you can see right here, if you have x raised to the p over n, it's the same thing as the nth root of x to the p. So an example of that would be if you have x to the 2/3, that'd be the same thing as the third root of x to the second. So that's fractional exponents. Now with that being said, when you have a fractional exponent, looking at the root, if it's an even root, like a square root, a fourth root, a sixth root, your graph would look something like this. Okay, that's with a positive lead coefficient as well. If you have a third root, a fifth root, a seventh root, then your graph would look something like this. I like to call that guy an Egyptian guy. And then we have all the various parts of those functions down below, and we've been analyzing functions. So that's what we have to deal with when your exponent is a fraction. Now the last thing I want to go over and discuss is solving radical equations. So you can see this equation, we have to solve for x, and we have a square root in it. So what you want to try and do is get the square root by itself, and then once it is by itself, then you can square both sides to eliminate the square root. So what I'm going to do is I'm going to add 2 to both sides of this equation. That would give me 2x plus 2 on the left. It gives me the square root of 100 minus 12x on the right. Then we square both sides, and in squaring both sides, we're going to cancel off the square root with the square on the right-hand side. It's the left-hand side that a lot of people make errors on. Now, if you take 2x plus 2, and you have to multiply it with itself, and that should equal 100 minus 12x. So if we continue with that, so that would give us 4x squared plus 8x plus 4 if we FOIL equals 100, whoops, not 1,000, but 100, minus 12x. Move everything onto one side, we'd have 4x squared plus 20x minus 96. Divide everything by 4, and that gives us quadratic equation looks like this. From there, we can factor and that would give us two solutions, -8 and +3. Now, anytime you solve an equation that has a square root in it, like we just did, you have to check to see if your answers are extraneous. Extraneous solutions are answers that confirm algebraically. You follow all the rules of algebra and you get those answers, but they don't confirm numerically. You got to put them back in, and the left side has to equal the right side. So let's take 3 and let's put it in. If you put 3 into the left side, you get 6. If you put 3 into the right side, you're going to get the square root of 100 minus 36, then minus 2. So that would give us the square root of 64, which is 8. And certainly 6 equals 8 minus 2. So this is a real solution because when you put it back in, the left side equals the right side. If I do the same thing, but do it with the -8, I'd get a -16 on the left-hand side. On the right-hand side, it'd give me the square root of 100 plus 96, and then we have the minus 2. And so -16, does it equal, see, the square root of 196 is 14, and 14 minus 2 does not give us -16. Therefore, -8 is what we call an extraneous solution. It's not a real solution, it's an extraneous solution. And I'd like you to label any extraneous solutions like I just did there. So this particular problem has one real solution, one extraneous solution. Next example, very similar, but this time we have a cube root. So if you have a cube root, what you want to do is get that cube root by itself, then cube both sides. So we're going to subtract 14 to both sides, and that would give us 36. Then we're going to cube both sides. The cube root and the cube would cancel each other out. That would give us x minus 5 to the second power equals 46,656. Then what we'd want to do is we'd want to square root both sides, and in square rooting both sides, the square root and the square would cancel over here. That gives us x minus 5 equals, if we square root that value, we would get 216. Add 5 to both sides, and we get 221. Oops, try that again. 221. And now if we check to see if that is a real solution, well, actually we don't need to check if it's a real solution because cube roots never have extraneous solutions. Square roots and fourth roots can, but cube roots never have extraneous solutions. So that's solving radical equations. Get the radical by itself, then eliminate the radical by squaring both sides or cubing both sides depending upon the radical, and then continue to solve for x.